So welcome all you for the lecture. The topic of the lecture is stereospecific, stereoselective synthesis and Crams rule, and also we will discuss over here chiral separation. So in this topic we will have a discussion on the specific reaction, which is like stereoselective and stereospecific reaction. So here if you see there are in stereo there are two type of reaction which is very specific with respect to the site from where the specific reactant will attack on the particular center, and the stereo of the molecules will get changed. So here stereoselective reaction, as you can see here, these are the reactions that can give two different stereoisomer, but one of those stereoisomer is major while the other one is minor. So why this happens? Because this is due to the stereochemical control on the molecule, so that it can have a minimum energy or can get more stability. Or in other terms, you can also define it: stereoselective reactions are a reaction in which there is a choice of pathways, but the product stereoisomer is formed due to its, you can see, it's formed due to the reaction pathway being more favorable than the other available. So it will go through the more favorable way, so that the product formation will takes place. So the stereospecific reaction, if we see here, a reaction in which stereochemistry of the reactant completely determine the stereochemistry of the product without any other option. It means a reaction in which the stereochemistry of the reactant completely determines the stereochemistry of the product. It means the reactant stereochemistry plays a very important role to see what will be the stereochemistry of the product. So in this reaction, this is stereospecific reaction. It means reactant stereochemistry is important, to which will in a later stage will determine the stereochemistry of the the starting material or the substrate. But if you see the difference between, what is the difference here in stereoselective reaction, here you can say they are the reaction which give two different isomer, but one of the stereoisomer will be the major product. So you might have seen in a reaction, in general organic reaction, there might be had written like that, one is major product and another one is minor product. Or it can give also in a form of percentage, like 90% of one particular product and another 10% is another product. So here, which will be the major product, that is called the product by which that is being forming is called stereoselective reaction. And here if you see, there are number of reaction. So if you see, with the help of different reagents like alkene, if you are taking, so you can see here in case of also epoxidation reaction. So here it is like titanium isopropoxide is being taken as a as a reagents here. So you will see here the product formation is 2% and 98%. So it means you can say one product is making more with respect to the another one. So the stereoselective reaction, you can have a different type of examples which you can mention over in during the explanation. So in the above, if you see in the above example, we have the when a stereospecific reaction is being there, so the product will be mostly, in case of like trans-stelbene, it gives a specific stereoisomer for a product which is a meso compound. In case of cis-stelbene, it gives a pair of enantiomer, and due to the stereospecificity, the halogenation of a reaction mechanism, anti-addition, trans-stelbene will never give you a pair of enantiomer. So it means this all products depends upon the stereoselective and stereospecific way, which product will be more or less. And if suppose the product determination will be stereospecific, means if that stereochemistry of the reactant will decide that reaction which will be the major or which. Here if you see in case of Crams rule, which is also very important, Crams rule, what it said here, because this is said from where the reactant will react in case of nucleophilic reactions. So in especially in ketones, so in certain non-catalytic reactions, that diastereomers will be predominant, which could be, you all know, I think, because already we have discussed on the stereomers, like diastereomers and all. So from entering group from the least hindered side, so here, like if suppose you are putting your structure in form of Newman projection, so the attacking group or the nucleophile will attack, like in case of ketone, the carbon will be, the carbon will be, in case of like a ketone, you are putting in a carbon like one front carbon, one in rear carbon in Newman projection. So the attacking group will attack from that direction, from where it will feel a very least hindrance or very small group if it is there. So from the least bulky group, or least, or you can say very small group if it is there, so it will attach from that side. So this is that carb is adjustment is called asymmetric center, that attached to the adjacent asymmetric center. Whatever the asymmetric center is there, so the group or atom which is very small or very least bulky, from that direction the nucleophile will attack on that particular carbon. So developing Crams are early explanation for some cases. Asymmetric induction, a process where one stereoisomer enters influence the configuration of the other stereo center. So it means from which direction it is attack will takes place in case of the nucleophile, so that will also alter the, or will influence the configuration of the other stereo center if there are two stereo center is present. So you can see from here there are number of this kind of like ketone, as I said, from this. So you can put in different wedge form as we discuss. So here you can see the major product is this one, and minor product is this one. So here if you see from this Newman projection, so this is the attack is from the least hindered side. Here, like this is a phenyl group, methyl, and hydrogen and methyl group. So you can see that this hydrogen is the very smallest group among them. So the attack of the like hydride ion, if it is you are reacting with this, so hydride is going from the least hindered side, and then the product formation is making, means major product, major diastereomers. And further, in case of there is a least probability of attacking from the bulky group like the phenyl group or methyl group. So that will, if there are certain product is being forming, so it means that will be the least one. So that will form very least amount. So Falcon has given in a different model applied in scenario where X is an electronegative group. The polar Falcon and model postulates that the observed stereochemistry arises due to the hyperconjugative stabilization arising from the anti-periplanar interaction between the CX anti-bonding sigma star bonding orbital and forming a bonds. So Falcon model is also there. Now coming to the topics which is also very important here in this lecture is chiral separation. So as you know, in case of many reaction, if there are a chiral species is being formed, or different different chiral compound is being forming, then how can we can separate them? So there are number of techniques among them, like such as fractional distillation, crystallization, adsorption techniques cannot be used in such case for the separation of enantiomer. When we are talking about the enantiomer which is having the chiral center, so in this case there are special needs or techniques is required to separate them, which is generally to enantiomer if it is there, that is racemic mixture. So the important, some of the important techniques are here, like mechanical separation, preferential crystallization, biochemical methods, and resolution through the formation of diastereomer. There you can say chemical method, chromatographic method, so many more methods, and these are the most important methods which is being used. So here in mechanical separation, this is developed by 1948 by the Pasteur. he provided to segregate the racemic mixture of tartaric acid enantiomer plus and minus. So he found that racemic sodium ammonium tartrate was crystallized below 300 Kelvin. Two types of crystal were obtained. These crystals distinguish hemihedral phase and were non-superimposable. So he separated them with tweezer and magnifying glasses. So here the limitation of this technique is this is the oldest techniques and having quite limitations. So this method is painstaking means quite time consuming. So it is of limited use, being application to those compound only which can crystallize as two well-defined types of crystal. So these are what is the complication over these techniques. Another techniques which is uh, preferential crystallization is another way of this is the preferential crystallization is closely related to the mechanical separation of crystal like the same previous method. So the you can say the super saturated solution of the racemic mixture is inoculated with a crystal of one of the enantiomer or an isomorphous crystal of another chiral compound. For example, when the saturated solution, because here you can take many more example, but one of the example which is sodium ammonium tartrate is seeded with the crystal of one of the pure enantiomer or a crystal. So sodium ammonium tartrate crystal out first. This method is called the entertainment and the seed crystal is called entertainer. So these are the some of the previous and old techniques you can say. Another techniques which is biochemical method. So these are especially if bio word has been added, so these are some microbes or enzymes are highly stereoselective reaction. So they will if they are a stereoselective, so they will select a particular kind of enantiomer over the another one. So with the help of these techniques you can segregate them, you can resolute them, or resolution like chiral separation we are talking here. So in case of here you can see fermentation of plus tartaric, because this is plus minor tartaric acid in presence of yeast or mold will like penicillium glucum. So plus tartaric acid is completely consumed, leaving behind minus tartaric acid. So one enantiomer is getting to be segregated over the other, and plus minus amino acid is also can be segregated by the by the hydrolyzed way. Acetyl group are hydrolyzed away, only acetyl derivative of L amino acid will be left behind. So here there are certain limitation as well. These reactions are to be carried out in dilute solution, so the product become very difficult to find out or to segregate. There is loss of one enantiomer which is consumed by the microorganism or the enzymes you are using over there. So only you will get, apart from two racemic mixture, you will get only one enantiomer over the other. So this is what is the drawback of this techniques. There are certain drawbacks of each and every technique. So here the chemical method, if you see, here are different steps. A racemic mixture like plus minus reacts with optically pure reagents. You have to react with the optically pure reagents which is having plus or minus or in terms of because already we discussed about the their RS nomenclature or D and L form, so that these are also represented in plus or minus. So you can understand from the concept which we have had a discussion on a previous lectures video also. So give a mixture of two products which are distereomers, the reagents plus or minus B is called the resolving agent. So here which one is resolving or removing the another one from another from the mixture of the from the mixture of the enantiomer like plus minus. So that is called resolving agent. So here you can say like B is attaching with the plus of A enantiomer. So similarly this B is also attaching separately with a minus A enantiomer. So in second step, the mixture of the diisomer obtained above can be separated using the method of fractional distillation and fractional crystallization. So the pure diastereomer are then decomposed each into the corresponding enantiomer and the original optical active reagents, which are then segregated or separate out. So this way, by the help of a particular kind of chemicals here, AB is, it is representing the individual mixture, like here, racemic mixture of a type of molecules if they're in a solution, or this is a B type of resolving agent which is resolving this with the help of their specific characteristics with respect to these racemic mixture. Then only you can segregate it with the help of chemical methods. Now you can see here these tartaric acid, and there are different way by which you can check it out here, like in case of tartaric acid, cinchonidine, and tartaric minus tartaric acid. So these can be segregated here, plus tartaric acid in crystallized form, and minus tartaric acid also can be segregated with the different chemicals, like sulfuric acid is being used here. Here also dilute sulfuric acid, and you will find at the end of the whole segregation process, you will be able to separate out all the relevant isomer from the racemic mixture. So the another way here, you can say similarly the resolution of the plus minus base with the optical active acid. So if you're having a base kind of so that can be changed with the help of like plus acid here. So you will get different salt diastereomers separable. These are, you can segregate like plus plus or minus plus. I hope you all might know what is the meaning of diastereomers, because these are the diastereomers that you can see. If plus plus, and if it comes minus minus, then that will be the enantiomer. But you can see the chiral center, it means two chiral center if it is there, which is having RR, and another is having SR. So these two are component of organic substance or organic molecule will be diastereomers. So those can be segregated with the help of this way. So this is very important once we are talking about the separation from the different methods and the use of different chemicals. So that helps to, because it is in a, during the chemical synthesis, it is very difficult to separate out them. In like the common methods will not help over here. So there are certain approach has to be, we have to go, and then only it can separate out. So here if you see the advantage of chemical methods, you can see here the chemical method of resolution is widely used and has the advantage that both the enantiomer are obtained, because since no one or no any of the enantiomer is getting to be consumed by, like we had seen in a biochemical method, because the enzyme is being trapping or is being removing one enantiomer completely from the mixture. So you are getting there only one enantiomer. So that was the limitation of that biochemical method as well. So here you are getting both the enantiomers separately, and because the resolving agent is resolving one enantiomer at a once and another enantiomer in a second time. So this method will be successful if the following conditions are fulfilled. So here overall, once we see how does these will be, condition will be fulfilled. So there some condition is required to check whether this will be fulfilled or not. So the resolving agent should be optically pure. This is the foremost condition. If that is not optically pure, means here whatever the mixture like plus or minus, so the resolving agent, that should be very pure form. If there is a contamination, then there will be some kind of interaction or some kind of interfere in during the course of separation. So that needs to be kept in mind. The substrate racemic mixture and the resolving agent should have a suitable functional group for reaction to occur. Means you cannot take any kind of resolving agent for a any kind of if you have a racemic mixture. It means you have to know the mechanism, you have to be aware of the actual structural information you have prior before going to these kind of separation. So then only the suitable reagents or you can resolving agents will help to separate the individual isomer from the Otherwise, what will happen? Yeah, because if there is no specific region for the reaction, because having some certain interaction, then it will be very difficult to separate them. So the resolving agent should be cheap and be capable of regeneration and recycling. So this is, if you see in environmental point of view, if you are using number of chemicals, if that is not recyclable, not regenerating power, then that will be create a sludge problem and many more other problems for the environment as well. So that should be cost effective, at the same time that has to some beneficial with respect to segregate, to separate, and to regenerate and reuse like that. If that is that kind of resolving agent, then it will be excellent for such kind of separation. So many of the researchers, they are also working in these areas, who are developing these kind of particular chemicals by modification, by with the help of a different mechanism, so that we can change, we can replace, we can segregate particular kind of enantiomer. Because now I hope you might be getting why these methods has been discussed in detail. Because for each and every production of, like in a chemical industry, if suppose you want a particular kind of enantiomer for the production of some particular chemicals, so you required at that time that particular kind of enantiomer. If you don't have that particular enantiomer, so your cost and economy will be very high for the production of any of the compounds. So these separation are very important once you are taking a particular enantiomer. Even in medicine formation, making of the drugs, there are certain particular enantiomer is having certain kind of specific properties with respect to their use, and their due to the optical activity, they can otherwise react differently and will have no any medicinal value. So for that point of view, that is also required to see whether that is useful or not. So these techniques. So now the chromatographic method is another method which is also very important. So chromatography, I hope you all might be aware of that. What is chromatography? So these techniques were initially by the Greeks. They had used it for the color separation, but now these are very advanced techniques in terms of, if we're talking about the green chromatographic methods. So simple like thin layer chromatography to now gas chromatography, high performance liquid chromatography. So many more advanced technique is available. So here the rate of movement of the two enantiomer through the column should be different due to difference in the extent of adsorption, because the each and every enantiomer with respect to the surface or with respect to the column which is having filled with some certain kind of coating, so that is having different interaction with the molecules on the surface, so they will segregate according to that. So each and every enantiomer have the different rate of movement towards the detector, so they will segregate and they will separate with a different time interval. So separation by elution with suitable solvent is required over here. If you have a suitable solvent, then you can easily separate them. So this method has an advantage over the chemical separation, as the enantiomer need not to convert it into diastereomer. So in earlier example in chemical methods, we had seen that there is different conversion and different resolving agent is required to convert them in a different forms, and then we are able to separate them. But here such kind of conversion is not required. So directly with the help of, due to their you know different extent of adsorption on the surface of the column, which is generally like in gas chromatography if you are talking, or high performance liquid chromatography. So there is a column from where no from where you are purging your solution or particular sample to the once that it does not comes to the detector. So that is a like a 30-meter length column, or more than even 45-meter length of the column, because this is in coiled form in case of like high performance liquid chromatography and other chromatographic techniques. So techniques include paper column, thin layer, as I said, and liquid chromatograph like high performance liquid chromatograph. So for gas, this is gas chromatography can be used for the separation of such kind of enantiomer. And solvent selection is very important again here. So you have to keep in mind what kind of condition is required to do these kind of separation. So from the overall discussion, if you see, we have had a discussion in details about the stereospecific, stereoselective synthesis. We had seen some of the reaction. How does the stereoselective reaction has or stereospecific reaction takes place, and how the one particular kind of enantiomer is takes more no formation in a higher percentage over the another one. So that is all about depends upon also the stereochemistry of the reactant as well, or the substrate as well. We also discuss about the Crams rule, or which is also called asymmetric synthesis or Crams rule. So Crams rule, we also seen that how does particular nucleophile attacks from the smaller side of the groups to keep that the steric hindrance and other hindrance at the least, so that it can make a products with in a major or minor product, as we have seen. So different kind of techniques we also discuss to how to separate the enantiomer, and which is called also the chiral separation, because there are in a general practice in a reaction when you go for the organic synthesis, this is happens. So how can we separate them? So this is the chiral separation. Is there are a number of techniques, and one or other is having the benefit, and some have their specific limitations, so we cannot use those techniques, and only we have to go for the particular kind of techniques. And over them you had seen the chromatographic technique was one of the best way to separate the chiral compound. So here a few of the references from where these content has been taken. So the material presented in this lecture has been taken from various books, internets, websites, and this slides are only for the instructional purpose, has been prepared, and only for the purpose of instruction. And number of references you can refer for further more to go in more details about the topics and the subjects. So thank you so much for watching this videos and listening this video lecture. Thank you so much.